the technology stores and retrieves energy. Push off the ground, pushes back on you. So equal and opposite reaction. Hence Sir Isaac Newton, hence Newton. Technology is very, very difficult to make, and it's very unusual. This is one of the early shoes, pre-launch, and you can see that it has an unusual outer sole. Now, inside the shoe is some very clever technology. 13 worldwide patents on how this works. It's quite hard to explain, so I'll do a very simple job starting with running shoes and a slight history of running shoes. Over the centuries, you'll see that shoes, always pretty much built for walking, have had a bit of a heel lift. So modern running shoes, the last 30-40 years, have introduced the same thing. There's a standard heel lift. The standard heel lift is 24 millimeters under the heel, so it's 1 inch. 12 millimeters under the forefoot or the ball of the foot, which is ½ an inch, which means you're on a ½ inch high heel. Now, if you take your shoes off and duct tape ½ an inch of foam onto your heel and you run, even with a level foot, what's going to hit the ground first? The ½ inch of foam under your heel. So that's what everyone's been running on for 30 or 40 years. 80% of runners in the US are injured at any given time. 80%, 80. And that's because of the heel lift. It's very conclusive. The running shoe industry knows this. Walking gait is not the athletic position, because there's no impact to speak of. But when you start to run, you assume quite a different position naturally. So the natural biomechanic of running is in that flex position. They actually land on your midfoot, what we call a forefoot, so anything from the middle of the foot forward. And everything from the balance point on the ball of your foot, it's a big spring, so very, very protective. And when you're in a flex position, all your joints line up. If you're in an unflexed position, it's very unstable. You don't run like that naturally. You run like in this flex position naturally. MIT has 2 studies. Harvard has just finished one. University of Heidelberg in Germany has just done one. University of Newcastle in Australia is on their 3rd go around. And they're all basically, this is the only shoe that really you can run in on a hard, aggressive urban surface and not get injured from the nasty stuff, but also run naturally because it's effectively level. So they basically use our shoe as the natural running shoe and then everyone else's shoe. And conclusively across every study, they all say the same thing. Reduces injury, more protective, much more energy return. They're all saying the same thing. The public doesn't know it. The public believes firmly that, because they've been educated for 30 or 40 years, that you need to have this big built-up heel and it's all about heel striking, and what they don't realize, it's also a thing that causes injury. And it's not natural. So we're one of many companies. All companies are doing it now. We started it, pretty much. But now every shoe has a forefoot, midfoot shoe.
The hand-built prototype took about 360 hours to build. But you'll never see this again. This is about 100% energy return. Basically, we'll come back to the point of where you drop it. And the number of times that it continues to bounce is continued store and retrieval of energy. So the other ability of this shoe was it incorporates the patents as to adapt to canted terrain and to have multiple stages of cushion and return. So this encompasses a lot of what we've done over the years. The real ease of flexibility between the mets and the toes, the way the foot works, metatarsal region and the toe region. So this is developed by an associate of ours, but it was stuck in this position. So this was the actual aha moment that Brian Russell developed. But to get it to market was a whole different story. And that's where Jerry and I took over. And it got to a point where, Danny, if it's going to get done, you have to redesign it into something very simple. And so went from about 16 ounces to 10 ounces. So we had to say, even through design and marketing, because you have to be able to get the product out, even if it's a better mousetrap, you have to be able to get it out to say, here's why it's better. We just felt people were not, ready to accept a shoe this radical, a no foam shoe with this unstable looking heel. It's actually stable. So what I did was I internalized this part, which is next to the heel bone, and it protrudes through here. So I said that, hey, they can't understand this, but they can understand this if I internalize it. And this was still too heavy, so we want it to be light so the foot can work with it. So we reduced the weight through the upper, through the outer sole, and really focused on the technology working in the forefoot, these lugs moving in the forefoot. So this was the ability to store and retrieve and lever, which are all great physics theories, and then that led us from the companies that we were before. Brytech was an R&D company, and then we became Boulder Footwear, and then we became Newton Running. So that's the brief history of 15 years of research and development. What we did was, through this research of afferent feedback, is we placed a firm plate right next to the bones up here. So your foot can actually sit on a firm surface and actually communicate through the ground and feel this lug. And so because this lug protrudes from the main bottom surface, but with the movement, this action-reaction technology, this simple third law of Newton, we have a greater shock absorber and a communicator and a lever and an energy returner. Because this membrane is more like muscle and tendon, and now we're giving the firmness to communicate. So we have this ability to, the foot without footwear on is 30% more efficient than when you put shoes on. We've now taken all that away and giving you this 30% back, 30% energy return, 40% cushioning. So you start with the 2D drawing, and we're mapping out the chambers and the actuator lugs and the pattern of the material. So we start with that, and now move to 3D. To reconfirm that is typically go into a wooden model, and this is the outer sole part. So this would simulate the rubber pieces that we're making. So this would be the outer sole rubber component, which would then turn into this. All right? And then each one of these, this is called a wooden model. And so it's this, the CAD machine will cut out this exact thickness and this exact pattern, and we measure this and check the design, and if that's ready to go, then we've confirmed that this is right, and then you can go into metal tooling, which will produce the final part. So the stages are pretty much like of any other development are 2D, 3D CAD, 3D models, and rapid prototype. Our main thing is if you can try the shoe and feel how different it is, it's so intriguing, then it's an easy sell. The shoe sells itself once you actually get to try it on, because it's so dynamic. You try every shoe else on the market, it's about how the shoe fits your foot, and not so much about the dynamic communication and feel that you get from a Newton.